Hello and welcome back to class. It's another beautiful night, and today we will be going over the builder pattern. I'm waiting till the last couple people come in. Hello, good evening. Good evening. Okay, looks like everyone's here. Wow. Wow. Let me just started. Okay, welcome back. Welcome back everyone. Uh, Today we're going to be going over the builder pattern. I know, many questions, many questions. I'll leave those until I get past the schedule so that you know if your question is going to be answered already. Okay, let's begin. Let us begin with the schedule, as always. Okay, so first we're going to go over what builders are and what you do to write them. And then we have three amazing cases. Okay, I want to see everyone excited for these because these are amazing examples. We have the responsibility example, we have the read-only immutability example, and then we have the bucket brigade. So all of you, get ready because this is good stuff. Okay, let's begin with asking what? Yeah. Yeah. Okay. Let's begin with asking what builders are. What are builders? Well, builders are classes that are solely responsible for returning an instance of another class. And now you don't necessarily need your builder to be nested in your original class. You can still write a builder and have it not be nested, but nesting them, as you will see later, good practice, it can lead to even better results. But let's go over these 3 points, right? Basically, it's a class that takes multiple parameters in somehow, i.e. through setters, and it will return an instance of a class out. And the point, why? Why is it important? There are a couple good reasons, and one of them is that you can hide constructors from users of your code. So you can force them to use your builder. We'll get into assurances later. And I mean, it's just good practice, makes your code legible, makes your code uh, easy to write, easy to read. Everyone likes it, right? We'll get into a lot of the specifics later, but on the bottom here of the slide, you can see, can you see that? In the back, can you see that? Okay, yes, so you could see here, we have an instance of a class being made, and then an instance of a class being made with a builder. So the first one is made with just the default constructor. The second is made with a builder. You might say right now, man, this is looking a bit long and cumbersome. Don't worry, get into it. Okay. Let's talk about writing builders. Right? How are you going to write a builder? How are you going to upgrade your system? So there are 3 essential steps, 2 recommended ones. Let's go over all of them. So the first step is to create a nested class named builder. So like I mentioned before, it doesn't necessarily need to be named nested or named builder, but it doesn't have to be nested because as long as you can access the constructor of the class you're trying to build from the builder class, you're fine, you're golden, but I would recommend making it nested. You can make a new instance of a nested class by calling the main, the outer class, dot the nested class name. And the second step is to add cached mutable variables for the parameters which you will want to eventually pass into the outer class's constructor. So obviously, you're going to still have a constructor for the outer class. You're going to want cached mutable variables in your nested class. Keep track of your progress. Number 3, Right, setter functions. So this is how are you going to set the mutable variables, the cached mutable variables? You're going to use setter functions. And you probably want to have a decent naming convention. So usually you can say with foo, with bar, is baz, add quux. So you have all of these functions. You want to make the language clear. You want to make the language similar so that when someone has a good IDE, then their IDE will assist them with their journey. So these two examples just take strings. That's not necessarily what you're going to be passing. You're going to be passing one or more parameters. You might not pass a parameter. You might have a function that toggles a Boolean or something. Very possible. And then let's talk about the recommended. Yeah? Okay, so the question was, in what's the context for the line? Yeah, so this line right here, with foo, with bar, it's just a snippet. You could see you're going to need to call new outer class dot builder, and then you can say dot with foo, dot with bar, and then you say dot build at the end. Yeah, so we're just gonna go over that after as well. Okay, so moving on. Number 4 is number 5. Both recommendations. You want to make the outer constructor private and the outer classes variable is private and read-only. Good stuff. Okay, why? Why? Because it promotes the consistency, right? You have of your class. You have invariance. You know that your class is going to have final values, right? If you want to talk Java terms. You know that the variables you set are going to stay. They're not going to be mutated later. We will discuss that, I think, in example 2 in depth. But let's begin with example 1, responsibility. So the phrase, like the main phrase that you ask, the question that you ask here, should this be my responsibility? Is this my responsibility? Look at this class right here. Look at what it's doing, right? You have a constructor for the class, and it's setting the 2 parameters that exist within the class. So far, so good. The first fishy thing that we're going to encounter here is the fact that it's calling a method, loading the sprite, and it's calling a method calculating the value. Why would this be counterproductive? Why would this be bad practice in general? Just think about it for a second. Why? Yeah? Yes, close. Yes, actually. So the reason why it's not great practice is because you are doing the loading and calculation live, and that can lead to a bad class. What does that mean, right? You can end up with a class that loads the wrong sprite in the sense that it doesn't exist, right? It tries to load a sprite name that doesn't exist. The loader returns null or a default value or something. It's a bad instance of the class. Or maybe the value, calculate value, it's doing this computation at the last possible second. Why? Why? When instead you could have something that looks like this. Read only, and all you take is a sprite and a value. Now you can't do this and write the code well without a builder, right? Because obviously if you do this, you're going to be either passing as variables the function calls, very bad, or you're going to be doing individual checks on each instance that you make of the class to check if the sprite is valid. Now, if you have a builder, on the other hand, your builder can check if the sprite and the value are not empty or null or the wrong value, right? It can check that the sprite exists. It can prevent you from creating a painting, from building a painting, if there is no good sprite, right? And that's where you shift the responsibility. You're giving the responsibility of loading these values to someone else, to another class, right? Which is really good practice because you are nipping the problems that you might encounter in the bud, which is good. And now we're going to get into an example. This example 2, it surrounds fish, right? Um, and I want you to take a look at this. Yeah, I see. I see you guys laughing. I want you to take a look at this class and tell me why this is bad. Why this looks bad. Yes. Precisely because it has 3 non-read-only variables. And not only are they non-read-only, but they're not, it's because they're not getting set in the constructor. You're going to have a function that looks like this. In the class, populate catch info, you are setting the variables, a setter. And it's not good at all. This is not good at all. Terrible. Forget about it. Why? Because look at this. These are mutable variables. They're just sitting there, and most importantly, you don't set them on construction, so guess what? You can have a fish that exists without these variables set. No good. Very bad. Why? Well, this is a fish. But when you're writing code, you might have something that really needs its values populated. Otherwise, something might go very wrong, right? What if the value, there's a value that you need to read at every step of the way, at every frame, maybe if it's a simulation or something, you're going to be grabbing bad values before you actually set it. You really want every instance of a fish to have all of its values populated. Where do we keep fish besides an aquarium? Haha. We keep them in a catalog. We're keeping them in a catalog in this instance. So, right, if you haven't encountered catalog in code, right, you're going to have like maybe a static class, a static list of instances of a class, and then you have a getter method, right? You get something out of the catalog. What can anyone tell me for bonus points, right? Bonus points. Why having this catalog is a little bit dubious? And the hint on the slide. Yes? Clone, exactly. So cloning, don't even get me started on cloning, right? Cloning it can lead to so many bugs. You forget to clone something. You forget to clone from a catalog. You access the catalog. You grab instances from the catalog, but you're always pointing to the same instance. So you end up with some nasty bugs. You don't know why all of your fish are affecting all of the other instances of your fish because you didn't clone, right? So this is on the right here. You see you already need a constructor with all of the parameters that set all of the parameters and a clone method that returns a new instance of the fish with all of the parameters cloned, right? And if you have a list of things, you need to clone every item in the list, and etc., etc., etc. No good. I don't approve, right? Not good at all. We want this. We want something that looks like this. Everything is read-only. Everything is immutable, right? Not only is it immutable, the constructor takes every value. So you know every time you make an instance of this class, you're going to be passing every value that you want. And this is this is a good practice. And let's ask, what is the benefit of a builder here? And also there's like a discard, like you tell me. You're looking at me funny because I just said that you can't pass immediately who caught it, where it was caught, and when it was caught when you instantiate it. Because obviously, how are you going to do that? Well, let's talk about let's write the builder first, and then let's talk about that question. So here I just have a very you just autofill with your mind the code, and here we have the build method of the fish builder. And as you can see, the build method takes the three parameters for uh, the live uh, the live variables. And look at that. It returns a new fish. It passes all the variables. So you're still looking at me with this stare like, how are we going to do this? And I will show you, right? Here there obviously should be some weights, right? Maybe as a default. So the thing with a builder, actually, this is an excellent example of why a builder is very safe. Imagine that the fish builder, as you can see, has a constructor that takes the name of the fish. In the builder, it'll probably have either -1 for the weight, or 0 for the default weight, or 20 kilograms. I think that's a lot for the weight for any given fish. So if you forget to actually call the method, which we will call now to exemplify good practice, I'm going to say 1 kilogram for a salmon. I don't actually know. I don't actually know. Oh man, I don't actually know how heavy a salmon is. So let's fill these out live, so to exemplify what we mean. Dot builder dot with weight. And I'm going to make the gar weigh 1.5 and the minnow weigh 0.2 and the tuna weigh, I have no idea, 5 kilograms, 10 kilograms. I'm probably very off. I see you guys in the back laughing. Yeah, I don't know why it's not letting me. Obviously, these are not going to be colored properly. That's fine. So let us get back to the slide. Okay, so now we have some builders, and we have the with weights, right? We sort of fixed the problem. Okay, you have a catalog of builders, and now your getter, look at what the getter can do. The getter can actually take the name that you're searching for, along with the rest of the variables, who caught it, where it was caught, when it was caught, and then it can return a built instance, and it can pass those variables through. What does this mean? No cloning required, right? Because you have a catalog of builders, and the catalog of builders will return a new instance when you call build, so you don't have to worry about cloning, at least in this instance. Maybe somewhere else in your code you need to clone, but for now, this looks extra good. Let's talk about example 3, the bucket brigade. So the bucket brigade is it's whenever you have an instance of a class, right? And you're passing it around, just like a real bucket brigade in real life. You will have a line of people from a body of water to a fire. The only job that each person has is to pass the water along. Now, in a bucket brigade in code, you might have a class being passed around, and different things happen to it, right? Maybe it's a package, for example, is supposed to be a nice, easy example to understand. You have a package that wants to be passed around before it's finally used for something, right? And as you can see, the builder has a bunch of different functions. Add stamp, add contents with, we have the parameters of content. Oh, no, yeah, that's fine. That's a class. We have a mailing address, a return address, a decoration, adder. So all of these things will modify the instance of a builder. Now, why is this good practice? Imagine the same scenario as the fish. Right, you have a fish in the world. You may encounter a fish in the world without those parameters set if something goes wrong. But in this case, you're actually, if you don't have a builder, you just pass a package around, you know that you're going to have a fish in the world without those parameters set already, and a package. So you're going to have a package in the world without all its parameters set already, And that's not great because you do want this package instance to be passed around the Bucket Brigade until it's finally resolved. And essentially, using a builder will completely change that, because instead of passing around an instance of a package, you're passing around an instance of a package builder. And the package builder, it knows it's not a package. You can't do anything that you would normally do to a package to it. The only thing you can do is call these functions to add these variables, add these parameters, change these parameters, set these parameters. And it means at the end of the day, you can do one last thing. When you call build and you want to get an instance back, you can check if everything is fine. You can check if you have enough, I don't know, stamps for the weight of the package. You can check if the mailing address is correct. You can check if the return address is correct, if there is one, if one exists. And what's great is that you can assure yourself that a package that is currently getting built as a package builder will never get conflated with a package that is already built, has already passed your quality assurance, essentially, and to exist and live in your code. So this is the benefit. Those are the 3 examples. Let's get a bonus example. Very good for this pattern. Let's talk about legibility. As you can see here, there's a basic pet class, right? We have a pet class here. It has a bunch of default parameters along with the species and name. And right here, you can see that using a builder makes it a little bit easier to read, right? You can see these 2 cats getting created, Socrates and Jonesy. So clearly, right, Socrates sleeps 5 hours. That sounds like not a lot for a cat, but apparently it is true. Maybe it's talking about deep sleep or something. And his favorite food is treats. Okay, so we have these 2 variables, and then also we have Jonesy, and apparently there's a title in the pet class, not included in this constructor, not great. But the title is ship's cat, and we have with personality, personality.brave. And here's what you can do in your builder. The cached mutable parameters can have defaults, right? Maybe the default personality is friendly. So when you build Socrates the cat, he will already be friendly by default. His sleeping time range will be night by default. His nickname will not exist by default. He will trigger allergies by default, right? But you don't have to keep navigating this long constructor to do so. All right, let's wrap it up. Overall, builders, good for promoting invariants in your classes. Good for keeping them, I may say. Good for keeping your code clean and organized. Good for keeping your code legible, which falls under clean and organized, I guess. And it allows you to more safely clone out of catalogs. I would say build out of catalogs, right? It's always better to have an object built out of a catalog, right? Imagine that you are, putting these pieces together. You are customizing your output, and with it is the assurance that it's going to be a new instance. You don't have to worry about cloning. So, all right. So this is I think this is the end. Yeah, this is the end of the builder pattern talk, right? This is the end. So this is the end of the presentation, and I'm going to open up let's see, not the homework assignment. First, any questions? Oh, let me turn off this. Let me turn this off. All right, yeah, and in the back.